Work.
Okay.
Yeah.
I just didn't understand how it was like a slash.
Okay, so that one, alright, we'll start with there, and then, we'll move from there. Austin, you never sent me a picture, but send me, oh yeah, you're doing Monday, right?
Monday.
Not Thursday. Okay, just be aware, I forgot to update this agenda. This 6.2 right here, we're actually gonna skip. This is one of those things that once I understood it, is not bad whatsoever. However, it's something that I want everyone here for to cover the differences. So instead of doing 6.2 today, we're gonna do 6.3, which is a little bit more straightforward, more calculator based, and we can keep track that way. That was, I forgot to delete those. Alright, so say again. Yep, that's what we're gonna get into. Alright, so this was the homework that I left you with. Oh, the other thing I was gonna say is, please remember that, I haven't assigned any, AP Classroom stuff recently, but it is going to be time soon that I assign some. We're probably going to be testing, my guess is middle of next week, because we gotta get through probability. We gotta get at least one more full unit in before break. Okay. So calculate and interpret the expected value of x, right? So we say expected value because it's e of x. What's another way to say the expected value?
Average.
The average, right? Which type of average? There's two types of averages.
Sample population.
Sample and population, which one?
Population.
Population, right? Don't forget, what can you use to help with this? Your
Formula sheet.
formula sheet as well. You're not gonna have Google on the AP exam. But the calculator can help, the formula sheet definitely helps. What is the formula? Yeah, we might want to get that formula sheet out.
Why can't they just put like the formula sheet in like simple terms?
Because they put it in mathematically and statistically precise terms.
Why can't they do just a little bit like?
It should be like this.
Why can't you just complain a little bit less?
Hey,
Boom!
I mean,
Roasted. Okay.
I just say what everybody's thinking, and no one else says it.
I'm sure everybody else is thinking that.
Except Ashton, because he knows what's going on.
Pretty sure.
I mean, it seems
know what's
pretty
going on.
obvious
I'm
that
pretty
they
sure
put
you
the
know what's going on.
math terms.
Yeah.
It's not really hard
Okay.
concept.
Okay,
Alright, what's the equation?
I'm looking at, sum of x times, probability of x.
And so, like, if you understand how to read it, right, it is very straightforward. It's the sum of the value x times the probability of x. And so, when we look at the red-black bet, what is the first value of x? It helps Deacon when we're not on our phones.
Yeah.
Just trying to say what everyone else is thinking.
Okay.
What's the first value of x?
-1.
-1 times the probability.
20 over 38.
Okay? Then,
1.
so plus the 1 times,
18 over 38.
and so when I add those together, I get a -2 divided by 38, or I think it was negative 0.05 something. Did anybody get the decimal? I'm just gonna
2.6.
do it. 2.6, thank you. Alright. And so this is for the red-black bet. So I'm not going to write all of this out, but it does say to interpret. So we need to remember, what does that mean? This number is a what?
Average probability, so.
Be careful, it's an average. It's not a probability. It's based on a probability. It's based on a discrete random variable, but it's just an average, right? Average or expected value. Average of what?
Of the probabilities, or is that?
Not of the probabilities.
An average dollar amount.
The average dollar amount. What do these dollar amounts represent?
That game.
Net gain or net
Loss.
loss. So what is the average amount gained or loss?
average loss is 5 cents.
See, there we go. So like, we need to recognize that we're averaging these values of that context, the game, but it's negative. So these are the average amount of money. We can go ahead and say lost because it is lost. Lost with a red black bet is $0.0526 or about 5 cents, somewhere in there, right? It's just an average. And instead of average, I could have also said, instead of the average amount, I could have said the
Expected value.
expected value, right? So it's about that value, right? So we're using probabilities, but it's not an average probability, right? Like, and that's even a decimal, but it's not a probability, it's an amount of money,
Okay.
right? So it's the average of the random variable. By the way, I guess I should have made this X, capital X here, because that's to remind us that it's the expected value of the value X. Here's my value. These are just the probabilities that go with that value. That's the discrete random variable.
So why is it capital again?
Anytime it's talking about the variable, it's capitalized. Anytime it's talking about the value, it's lowercase. So variable, uppercase, value, lowercase. That's why I use -1 here. That's why I use a +1 here, because it's the value. But we use capital letters when we're talking about the variable. So for example, if I were to say, hey, what's the probability that capital X equals 1 for the red-black bet, notice how that's the fact that the variable equals the value 1. And that would be 18 out of 38. So capital, variable, lowercase, value. Go with that. Okay. If you play the second one here as well, so corner, you actually get exactly the same thing. I'm not going to write the full formula out, but it's -1 times 34 divided by 38, plus 8 times 4 divided by 38, which is that -0.0526 again. So the question I have for you is, which bet would you make?
Either.
If you had to pick one, if someone held a gun to your head, which one would you pick?
Corner.
Just either one.
Why?
I pick corner because the chances of like you lose the same amount on average, but at the same rate, like you stay in the game more.
Oh.
So like even though like the two bets like have like the same expected value, I think it's a better idea to pick corner because if you win, you get more.
So if you win, but it has such a low chance of winning, right? You could win here 18 out of 38 times, you're only going to win here 4 out of 38 times.
If you're feeling lucky, choose the corner.
Yeah, but how lucky is it when you do something random? So, I'll go ahead and tell you, it was a bit of a trick question. Hey, you know what we haven't calculated yet that should be an important part before you ever make a decision?
Standard deviation.
Standard deviation, right? Like we have a measure of center. The measures of center are exactly the same, but we still need the measure of, what's that standard deviation? It's a measure of variance. Well, variance, remember, is sigma squared. There's an S word from CUS that we use. It's a measure of spread, right? So that standard deviation is that measure of spread. Now, we do start by calculating the variance, or the standard deviation squared. And don't forget, like, the whole thing is this deviations from the mean, right? How do I calculate those deviations from the mean?
Value minus mean.
Value minus mean, that's my deviations, but what's the issue? If I do all the values minus the means, I end up getting, I add them all up, I get, well, I'm summing all of them, right? But if I take all the values minus the means and I add all those numbers up, I get 0. Remember, if I take a value and I subtract the mean from it, how we always got 0, which is why we then needed to
Square.
make sure that they're all positive, right? Look at that formula sheet. What's happening to the value minus the mean under standard deviation? The value minus mean is squared. Right? You got your formula sheet?
It's somewhere.
I would get it out, look at it, always go back to it. So value minus the mean.
There it is. I'm making ups for past time.
Okay, but
I'm paying attention.
alright, value minus mean squared. But when we're dealing with these discrete random variables, right, when we did just variables, we did n minus 1. But what are we going to do with these discrete random variables?
You're gonna multiply it by the probability of each of them.
Okay. Now remember on the AP exam, you need to write, it'll probably be more than something like this, and you need to, if they ask you to do something like this, you need to write it out. But do you have to actually calculate it by hand?
No.
No. Okay? So they want to see that you understand what the formula is and how to substitute into that formula. But I am personally, I just started with the corner. But I'm personally very rarely ever going to do this by hand. Okay, so that's that corner. Let's go ahead and type that in real quick, just calculate that. You can do the other one on your own, but so if we tried this one last night, some of us already had this information.
It's like 0.9986 once you squared it.
So like this right here is 0.9926.
Are you looking at for the red black bed or what did you?
I'm looking at the corner one right now.
Oh. No, the corner one was like 2.7620.
2.7620.
Yeah. Once it's squared out.
Okay. I got 7.62881. I might have made a mistake somewhere. I think that's right there. Someone check me on that.
I got like a 7.8.
Wasn't it 0.0526 here? Is that what you used?
Oh, I see.
Well, yeah, I was saying after I'd square root of it.
Ah. So don't forget that standard deviation. I used v of x over there, which means I'm looking at the variance, right? The standard deviation. I was going to get to that part next in a second. Yeah, I got 7.8. Okay. So this is my variance, that's sigma squared of that variable. What would I need to do to get the standard deviation though? Square root. Personally, I'm always just going to do the variance and then take the square root afterwards. You can use the formula if you're doing it by hand. Again, I would probably use a calculator. You said 2.76?
Yeah.
So this is that corner. If you do red black, you get a variance of 0.9972 and a standard deviation of I think that's what you said earlier for that standard deviation, right, Josh?
Yeah.
So, for the corner bet, for the red black, again, the major thing is to understand that it's the value minus the mean squared. That's that deviation squared to make sure it's positive. Then you multiply by the probability. And also, we're gonna use calculators to our advantage. But looking at it this way, which one are you more likely to go with? Once we include this spread here.
Well, it still depends on the type of person, doesn't it? 'Cause
Yeah, but
sometimes-
like logically, so not just like the person, but logically, which one makes the most sense?
Corner.
Why the corner?
There's a greater, like if you win, you get more money. And if you're gambling, you may as well go big.
Well, I mean, you stand to gain more from the corner, but you also stand to lose more. But similarly, you stand to gain less from the red-black, but you also lose less.
So, here's the thing, I actually do want you to think about it. If you're more frequently going to win with red-black, right? But if I'm only, and so this is where you want to recognize, if I'm only rolling once, if I'm only playing, is this roulette? Yeah. If I only play roulette once, which one am I gonna go with? I'm gonna go red-black, right? It gives me a greater chance, like there's a lower standard deviation, so there's a greater chance that I win a little bit, right? Less spread there. But if I'm gonna play multiple times, because of this greater spread over here, I might go with the corner bet. Notice, what is the most that I could lose in a single round of the corner bet?
$1.
$1, right? But I have this great spread here, larger spread, and so have you thought about the fact that this is a skewed right distribution? Right? Yeah. Because you have that value far off to the right, that's not going to happen very often. Notice that's pretty far to the right of my mean, very far to the right of my standard deviation, or not my standard deviation, very far to the right of my median. So it's a skewed right distribution, and so I might go with that if I'm playing several times in a row.
Well, the house always wins either way.
100%. How can we actually verify that based on these calculations that the house always wins?
The mean's negative.
The mean's negative, right? So on average, you're going to
Lose.
lose. The house wins long term no matter what. They make sure of that. Right? A couple people might win big, but overall, we're all just suckers to them.
You should just invest in the stock of the house,
No.
instead of
I
gambling.
wonder, can you invest, like, are there stock
actually,
options
they're
for
private.
casinos? I would say, I think they're usually private, yeah. So, which type of bet is better? Honestly, depends on you.
Invest in
Right.
the
Are you willing to have that greater variability in this case? Or do you want something that's more of a sure thing, lower spread? Does that make sense? So those are things to consider. Alright. There's a couple homework problems associated with it. Yeah, so this is getting into 6.2, pages 409 to 415. We're going to skip this as we're going to get back to tomorrow when everyone comes back. Instead, you're going to want to go into your notes until you get to a section that says 6.3, binomial distributions.
It should be like on page, so-called 7.
Yeah, I went in and I numbered them later after I printed them out because y'all pointed out that I forgot to number them. I'm not saying you're wrong. All right. The big thing again though is oh, by the way, I guess I forgot to talk about this. It's not just calculating, because we can use calculators to do that, it's also interpreting. What does this 2.762 mean?
That's the standard deviation.
Yeah, but what does that mean? So you gotta remember, there's a difference between reporting a value and interpreting that and explaining what that means.
The average distance from the mean.
So it is an average distance from the mean, but if I'm interpreting it, I gotta get it into context, right? So what does that average distance from the mean mean?
The
On average,
So on average,
the amount of money lost or gained with this for corner.
yeah, for the
Corner
corner bet,
is 2.762 standard deviations above or below the mean.
super
It
close.
would be dollars.
Dollars above.
2.76 to dollars above or below the mean, right? Because that's how many standard deviations.
One.
That is the standard deviation, right? So the on average or the typical amount of winnings or losses is $2.76 from the mean. Does that make sense?
Yeah.
For this one over here, and I think this one's even more plain, on average, right here, on average, the typical amount of money won or lost is how much from the mean?
Roughly $1.
Roughly $1, which makes sense because what was the average? A loss of 5 cents, and you either lose $1 or you gain $1, right? So it's about $1 no matter what way you go. Does that make sense? So interpret context. Don't just tell them that this is the standard deviation. You got to tell them what does that mean? Is the typical amount that the data is deviating or differing from the mean, but put it in context. Typical amount that the data differs from the mean, and it is one standard deviation. The z-score is how many standard deviations, right? The z-score is how many. All right. So conditions for a binomial setting. This is pages 430 to 434 from the book, and I want to do. I'm gonna come back to this. All right, I want to actually look at these sets of problems, and then we're going to go back to the stuff from the book. So let's say we roll. So determine whether the random variable. Nope, that's not what I wanted. This is going to be further into the binomial section. I want this where it says in many games involving dice. So it's going to be on the second page of binomial distributions, on the top. Okay. So in many games involving dice, rolling a 6 is desirable. Is that a fair thing to say? Yeah, right. Higher numbers. Probability of rolling a 6 when rolling a fair die is 1/6. If x is the number of 6s in 4 rolls of a fair die, then x is binomial with n equals 4, p equals 1/6. We'll talk about what that means in a second. Any guesses what we mean by n equals 4? That's our sample size, it's our number of rolls, right? But n is always a sample size. In this case, how many rolls? What does p stand for?
Probability.
Probability, right? We're not trying to trick you or anything like this. So there's probability. And so, what is the probability of that x is equal to 0, right? So what is the probability that the number of 6s rolled in what sample size? 4. What is the probability that that is 0?
5, 6, 5, 6,
5, 6, and 4.
So the probability of not getting a 6 is how much?
5, 6.
5, 6. The probability of not getting a 6 is,
5, 6.
why am I just multiplying these?
These are independent.
Ah, these things are independent?
Yeah.
Okay.
So you add dependent and multiply independent?
No, remember you add the unions, you multiply intersections, right? The probability of getting not a 6 and not a 6 and not a 6. So if it's an or, there's some kind of addition. If it's an and, it's some kind of multiplication.
So let's say it was a probability of getting 6 or a 1, you would add those.
Correct. And they're mutually exclusive, so you don't have to subtract the intersection. Yep. All right, so what do I get here?
5, 6, or 4.
Yep, what is that?
0.4823.
0.8423, is that what you said?
It's a 482.
Oh, I'm hearing things. Thank you, 4823, there we go. Nice. Okay, I'm gonna come back to the earlier notes in just a second after we tackled the second one. What is the probability that x equals 1? So we want how many 6s? 1/6, right? Or 1/6. So probability that x equals 1 is what?
1 minus that, or 0.4.
Well, so notice, does it say at least
Oh,
1?
No.
So it just wants 1.
So it'd be 5, 6 to the third times the 6.
What do we think about that?
What?
So where are you getting 5, 6 to the third?
I just put all my 5, 6 together because 3 of them have to
So we would have 3 failures, right? No 6. And then 1 success.
Does the order matter?
Oh, that's a good question. Does the order matter?
No.
They are independent, but is it possible to get, I don't know, a 6 and then a 1, a 2, and a 3? Well, let's just even say 6 and then a 6 complement, a 6 complement, and a 6 complement. That's a possibility, right?
Yeah.
What about not getting a 6, then getting a 6, then not getting a 6, and then not getting a 6?
It doesn't really matter though, because you just multiply it.
You are correct, but the question is, what is the probability of only getting 1 6? And if I'm rolling 4 different die, it can happen in any order. And it would still be counted as just getting 1 6.
So would you multiply the whole thing by 4? Because there's 4 different possibilities in which you can get 6.
So here's my sample space. Right? How many different ways are there to just get 1 6?
4.
4 different ways.
So you multiply that by 4.
So I would need to multiply this by 4. Notice, this is the probability of getting 1 6 and 3 not 6s. But how many different ways can I get just 1 6?
Oh, alright.
And I guess one way to think about it is, this is die 1, die 2, die 3, and die 4. And so I have to account for getting a 6 on any of those 4 die.
Okay.
Does that help explain that? I've actually never thought of explaining that way before, but I think that might help.
Yeah, so like, is there like a formula for it, like outside of that? or-
Oh, maybe there is. Well, hold on to that, hold on, I just want us to see something before we get into that formula sheet. Because yes, there's a formula, but even better than the formula, you know what's on your calculator? The calculator, yeah. But there's a thing called a binomial distribution that we're going to talk about. Okay, so I want to point this out. For the probability that x equals 2, right?
Mhm.
How many not 6s would I get? 2, right? So if I'm looking for the probability that I get 2, I would get 5, well, really we get 1 6 to the second and 5 6 to the second, right?
Yeah.
Because that'd be 2 successes and 2 failures. But now I have to think about all my die, and this is why we do want a formula. So I could get 6, 6, 6 complement, 6 complement. I could get, and so like you'd have to be super methodical to write all this out.
That'd take a while.
It would take a while, right? And so Ashton asked the right question earlier. Is there a, what?
Formula.
Formula, okay? And so, just want to finish writing these sample spaces out so that we can verify that our formula works. I think that is every possible combination of getting 2 6s and the rest not being a 6. I think that's right. We'll come back and check in a minute. If you'll notice, what I did is I started with 2 6s here at the top, and then 2 failures here, and so I just moved this 6 down 1 each time to get every possible combination where I get a 6 first, and then I let it be a failure first, and then 2 6s, and methodically did that as well. Okay, so look at your formula sheet. Anyone see anywhere on that formula sheet that might help us with binomial distributions?
Yeah, man, it says the binomial distribution with parameters in the field.
Oh, there's a formula for binomial distribution, like it tells you there's binomial distribution somewhere?
Yeah, yeah.
Oh, that's
it's
sweet.
simple.
Yeah, literally right there underneath discrete random variable, right, it says if x has a binomial distribution. Okay, so how many of us have ever seen this notation right here? By the way, I want you to notice, what does P represent?
Probably.
The probability of a, well, in general, for this one it was a 6, so we would consider that a success, right? Okay, so the probability of a success raised to the x, where that's how many successes we want. Remember how we use lowercase letters to represent the value that we want? So that's the probability of success raised to the number of successes. So 1 minus P would be the probability of failures raised to the, well, if we had 4 trials and we had 2 successes, then we had 2 failures, right?
Yeah.
And that's what we did right over there. If we wanted 1 success like we wanted here, the x would be 1, and the number of trials would be 4 minus 1, which gives me 3 failures like we had here. So it's just the probability of success raised to the number of successes, probability of failure raised to the number of failures. That's what all that notation means. This right here is called a combination. I know Deacon and Tyler have heard that term before.
Have I?
Yep. Because we talked about a math team.
Oh, yeah, you're right.
Yeah, okay. So here's what a combination is. So you will sometimes see a combination written this way. And sometimes you'll see it written this way. And I'm going to give you a little bit of background into what a combination is before I actually get to a combination. So a combination is a special example of a permutation. Well, it's a slight change to a permutation. If I were to ask you, right, let's say we have 20 people in a race, and I were to ask you, hey, what's the number of different ways that I could get first, second, and third place? 20, right, times 19 times 18, right? That's called a permutation. The permutation is n permutate x, that's n factorial, so that's how many total we have, divided by n minus x factorial. Ooh, do I need to go into factorials? Lex is like, yeah. Okay, factorial time. Alright, let's see if you can find out what a factorial is just by this example.
Oh,
Yikes.
I have the numbers. I hate 11. 7.
So what is a factorial?
The number and all numbers lower than it, multiplied by each other.
So 5 factorial is the number 5 multiplied by every integer below it. 4 factorial is 4 and it multiplied by every number below it. 7 factorial is the number 7 and every number below it.
Until
Is
1.
that just
Until
positive numbers?
Yeah. Just the integers. Except we do have a 0 factorial, and I'm sure there's something other than those, but I haven't studied them. For us, that's all we care about. 0 factorial is defined as 1. Okay? Just in case that shows up. Alright, so here's what we're looking at over here. So how many people did I say that were in this race? 20 factorial divided by, how many places did I want? 3. So 20 minus 3 is 17 factorial. We good with all of that? So we had 20 people divided by 20 minus 3. Okay? And so that's what gives me the 17 factorial. Now, here's the way we speed this up. 20 factorial is 20 times 19 times 18 times everything below it, right? But what is everything below that 18? That's going to be the same as 17 factorial. I'm going to stop there because what am I dividing by?
17 factorial.
What's anything divided by itself? 1. So 20 times 19 times 18. Okay? That's a permutation. By the way, you don't need to know permutations, but it's to set us up for what a combination is. So a permutation is important because the order matters. John coming in first place, Frank coming into second place, and Deacon coming into third place is different than Deacon in first, Frank in second, and John in third. That is also different from Frank, Deacon, John. So do you see how like all of those, like I'm using the same exact people, right?
Mm-hmm.
But because the order matters, I'm counting those as separate things. That's like if I were to talk about president, vice president, and secretary, right? The order there would matter because whether Austin's the president or whether Austin's the secretary is a different thing, isn't it? Okay? But what if the order didn't matter? What if we were just talking about senators? Does the order matter? If you're a senator, you're a senator. Talking about House of Representatives, does it matter the order that you're selected in? No. And so when the order doesn't matter, it's called a combination. Okay? So the difference between a combination and a permutation is this. N factorial divided by n minus x factorial. Does that look familiar?
Yeah.
That's literally the what?
The
Permutation. But if the order doesn't matter, right? So notice there are 3 examples here, but in a combination, when the order doesn't matter, this will be counted as how many?
1.
1. It's only counted as 1. Like, and there's more combinations of just these 3 people. So in the combination, the order does not matter, and so I actually need to divide by something else to reduce the number of options that I have, and that number I divide by is x factorial. Okay? By the way, just giving you background, literally you'll never have to actually do these calculations by hand. I just want you to understand that the calculator's not doing magic, okay? This is a mathematical thing. So, how many dice are we rolling?
4.
We're rolling 4 dice, right? So 4 factorial divided by, we have how many dice?
4.
4. How many successes did we want?
2.
So 4 minus 2 factorial. And how many successes did we want?
2 factorial.
Uh-huh. So 4 times 3 times 2 times 1 divided by, what's 4 minus 2?
2.
And 2 factorial would just be 2 times 1. Times 2 factorial is
2 by 1.
2 times 1.
So the 2's and the 1's cancel out 1 time.
And then what's 4 divided by 2?
2.
And what's 2 times 3?
6.
You mean these 6 different combinations that I read out here? So this combination formula gives me every combination possible when the order doesn't actually matter. Okay?
What you said when the order doesn't matter?
Mm-hmm.
Okay.
Because the dice, right, that's not in order, right? Like, if this die 3 is actually done first, that doesn't matter. What matters is where the 6 is on which die. But the order still doesn't matter when that die is rolled, okay? So, all of that to say, we need to understand n is going to be my number of what? Not the number of successes. That's my sample size. Remember, n is always sample size, right?
Yeah.
Okay? X is going to be my number of successes, right? N is always sample size. X is always the, no, what did I say? N is sample size. X is always the number of successes. And so that's right here. That's what this formula is telling us. Number of successes, no, number of trials or sample size, number of successes, times the probability of success raised to the number of successes. Probability of failure raised to the number of failures. And so I might make a note to myself, actually there's a part in the notes, we'll write it there. All that to say, by the way, what was 4 times this? Did we ever calculate that, anybody?
Would that be like the number of trials?
N is the number of trials or number of success, or
No,
N is the number of trials, the sample size.
That's the sample size, and then divided by number of successes.
Be careful, it's not divided by the number of successes, because there's no fraction
divided,
part.
but yeah.
We read this as N combination X.
Yes. I was thinking like
0.3858.
0.3858. Okay?
I should not to remember, but like that means it was 6 successful trials, right?
Well, there's 6 different combinations. Because remember, how many successful trials are there? There's only 2 trials that are successful. But how many ways can I get 2 successful trials? 6 of them. There's 6 combinations that give me 2 successful trials.
Okay.
Which is again why we call it a combination, right? There were 6 combinations. And so when I multiply this out, what was the probability that x equals 2? do?
0.1157.
That'd be nice if there was an easier way to do this, huh?
Yeah, really.
Yeah.
I mean,
So
it's
is
just
there
a
a
calculator,
just-
it's a binomial or
just saying that.
something.
Yeah, let's think about this logically. Let's look at our calculator really quickly. Oh my gosh, it must be really tough having a teacher try to show you easier ways to do things. What kind of page am I going to create?
Calculator?
Calculator page, yeah. Any guesses where I'm going to go from calculator page?
Menu.
Yeah, I want to do cool crap, so I'm going to hit the which button?
Menu.
Menu, then?
Check or statistics.
Yeah, statistics and distributions. And then you hit A for binomial.
So maybe statistics, but look at your options again. What unit are we in?
Probability.
We're in probability, right? I think you can go through statistics as well, but probability. Hey, by the way, what are those first three options there? Under probability. Factorial, permutations and combinations, right? So the calculator can do those for you separately, but we're dealing with what again? What is this thing called?
Binomial.
It's a binomial distribution. So I'm gonna go to distributions and,
Binomial PDF.
notice there's binomial PDF, there's gonna be a binomial CDF below it. So we've done normal, right? Some of y'all see that chi-squared in there, and we've done chi-squared if you've taken biology. But yeah, we're looking at binomial. Now, are we gonna use PDF or CDF?
CDF.
What did CDF stand for? What did that C, do you remember?
Combination.
Not combination, because I'm talking about the normal CDF. It was cumulative,
Yeah.
which means more than one. If I'm just looking at probability that x equals 0, then I'm only looking at 1. This is a probability density function. I want PDF if I'm only dealing with 1. So what are my number of trials? 4. What's my probability of success?
Are we doing 2 right now?
1 divided by 6. Well, 2 is our x value, the number of successes, right?
Which those
Are we doing
those
two or
your
three?
lower and upper bounds.
Remember, lower and upper bounds, you need to think about that normal distribution and the shading. What is in, that's my number of trials, that's my sample size. Did you do binomial PDF?
Oh, whoops, I accidentally did CDF, that's.
Gotcha. We're going to talk about that one in a second. Remember, CDF is when we're doing more than one value. PDF is when we're just doing one. Okay, so number of trials is 4, probability of success is 1/6. The x value that we want is 2 right now, because we want 2 what? Successes. Thank you, great, Okay. Huh. Man, that was a lot easier than putting all that into the calculator. Wouldn't you say? So, one thing I will point out to you is this. Can you use the calculator? Yes. Can you just type this out or write this out on the AP exam?
No.
No. You have to use the formula sheet to write out the formula and then put it into the calculator so you don't make mistakes.
Yay.
So do you plug in the numbers on the AP exam, or just write the formula?
So like what I would do is I would have written the probability that x equals 2 equals 4, choose 2, times the 1/6 raised to the second times the 1/6 raised to the second, which that one's easy enough, but usually it'll be more than just that, right?
I'm asking this because it doesn't look on.
Oh,
maybe-
156. Sorry, not 1/6 here. Yeah.
Does this in the book on like the homework? When we do like, let's say for like the normal distributions, we would inverse CDF. Do we have to put that
Inverse
in there?
normal.
Yeah, inverse normal. Do we have to put?
If
it
you
in there?
draw out the normal distribution and you show that you have the area and you're trying to get the z-score, you're good.
Alright.
You don't have to write out the calculator speak. If you've drawn the distribution or if you've labeled things like this, you're good.
Yeah.
And then just use the calculator to do the calculations. Now, here's one thing I want to point out to you before we continue. So let's do this really quickly. Go back to menu for me. Can you go to statistics? Yeah, you can do statistics as well, but I was doing, I do want you to go back to binomial PDF for me. Okay. How many trials we got? 4. What's probability of success? 1 out of 6. Notice how it says x value is optional? Just hit OK without putting an x value in. What do you think all these numbers are?
Probabilities of every one.
Do your sample space?
Yeah,
It is the sample space, so this would be when there's how many successes?
one.
No, it's a one.
First one is 0. then
0 successes.
Oh.
1 success.
2.
2 successes. 3 successes. And if you scroll to the right, 4 successes. Right? So if you don't put a specific x value in, it literally is a probability distribution. And so you can see them all there. What's the likelihood of getting all 4 of them as 6s? Super low.
Is the combination of getting 1 the same as the combination of getting 3?
No. That's a good question. Oh, you mean like just
The combination?
4 combination 1 and 4 combination 3?
Yes.
Yes. Yeah, because it would be 4 factorial, right, divided by 1 factorial times 3 factorial, or 4 factorial divided by 3 factorial times 1 factorial. Right, because the x and the n minus x would switch. Yes, the combination would be the same. Good question. By the way, what would I get if I added up all those probabilities?
1,
Why is it 1?
because they're all mutually exclusive.
Because they're what?
All mutually exclusive.
It's not just because they're mutually exclusive, that's the what? It's a probability distribution, it's also my
Sample space.
sample space. Remember guys, if I have the entire thing, if I have the whole sample space, I got everything in the club. I got a probability of 1. What's going on? Hit A.
It can't go under.
Number of trials.
I bet now I can.
Yeah, alright. So, now let's go fill in the notes that we need about this probability, this binomial probability distribution. Alright, so going back to the beginning, what are the conditions? Has anybody noticed anything that might have to be true for these binomial settings?
Mutual exclusivity.
So maybe they do, but is it possible to get 1 success and 2 successes at the same time?
1 success.
Yes, because if you have 2 sets, it 1 test. Right?
But if the goal is to only look at 1 success,
Oh, well, I guess not.
So, yeah, no.
Independence.
oh yeah, what was one of the first things that we saw? There has to be what?
Independence.
Independence. That's one of the first ones. What do we mean by binomial? What do we mean by bi?
2 numbers.
There's 2 numbers or 2 options, meaning either it is a success or it is a failure, right? Success or not success. So binomial. So success or failure, 2 options. Each trial needs to be what?
Independent.
Independent, right? What do the number of trials need to be? Whether we looked at 2 successes or 1 success or 3 successes,
Number of trials should remain the same across like the entire sample space.
if I'm looking at a sample space, those number of trials needs to be the same throughout. The term you'll usually hear is fixed, right? If I'm looking at the number of successes or the likelihood of 2 successes, I don't want to change the number of trials. I only want to look at 4 trials or 5 trials or something like that. I really should have had the book up for some of these details. Because I do want you to see where it is in the book. I close. Oh, there it is. What pages does it say the binomial distribution is on?
I just did 4:30.
4:30 is where it starts?
I think.
So once again, I need you to become familiar with your textbook and pay attention to those page numbers.
It's 4:30.
Okay. Alright, so, yeah, there it is. 4:30 is binomial and geometric. So binomial settings and binomial random variables. So, I guess that's what I should have said. The first condition, Deacon, can you hit those lights for me? Not binomial, because that's part of the little thing. Binary, right? So, in order to have a binomial setting, the possible outcomes can either be a success or they can be a failure. Binary. Each trial must be independent. The number of trials must be fixed. And what's the last one?
Each, the same probability.
Same probability.
Based on each trial.
Do we want those probabilities to change?
No.
No, right? If the probabilities change, then it's not a binomial distribution. Either the successes were always what probability?
The fixed one,
No. What was the probability of getting a 6?
like 1 out of 6.
1/6, right? It didn't matter which trial I was looking at. It's a probability of 1/6. Okay? We do not want those things to change. And so hear me clearly on this. On the AP exam, they may give you a free response question that is about a binomial distribution, but you know what they're not going to tell you?
It's a binomial distribution.
They're not going to tell you it's binomial, so what do you need to do to figure out if it's binomial? You need to check those conditions. Right? So you got to know that those are the conditions for a binomial distribution. And so if you are looking at a situation, you got to ask yourself, is each trial independent? Or is it binary? Is each trial independent? Number of trials, are they fixed? Same probability. And the acronym that we use oftentimes in stats is BINS. BINS, right? Is it a binomial distribution? Check your BINS on that one.
Wait, what's this?
Same probability. Say again. SNIB.
Nibs.
It's so close to being really cool with Snips from Ahsoka. Yeah.
From what?
Star Wars, man.
Man, Anakin Skywalker's apprentice, her name was Ahsoka Tano, but he called her Snips all the time.
I haven't watched a single Star Wars movie in my life.
That is actually
Same.
wild. That is
That's not even from the Star Wars movies, that's from the TV shows.
I don't watch
But
the shows either.
oh my gosh, Tyler, 1, you gotta watch it because you would love it. 2, you gotta watch it because you would love it. 3, you gotta watch it because you would love it.
I don't
Alright, what?
I don't watch any Star Wars.
So.
The TV shows are good. The new trilogy sucks, but like
I didn't say your view.
Rogue One was really good. The Mandalorian was really good.
Andor.
And Andor was one of my favorite TV shows in a long
I
time.
couldn't get into Andor. I watched like the first episode.
So Andor starts really slow, but it's like everything you want out of.
You're gonna have to
That
edit
is
your
boring.
videos
I enjoyed it.
because y'all just
I'm done. Hey, I'm done. Chill.
I'm not like
better
a-
topics.
I think
I might wanna know.
There are not better topics. Don't fighting words. Alright, so I think the next detail, hey guys, I think the next detail is what is a binomial random variable. Again, notice it's clearly defined in the book, right?
Here's my paper.
They have a nice bold or like green box every time there's a really important definition. So, what page was this? I think it's 432 by now. 434, wow. I lied. Yep, so binomial random variable. So the count of successes x in a binomial setting is a binomial random variable. Right? So if we have a binomial setting and when we're asked the question, hey, what is the probability of getting 2 successes? The binomial random variable is either getting 0, 1, 2, 3, or 4 successes. And a probability distribution, by the way, what do we mean by probability distribution again?
The distribution of the probability.
Man, that was awesome, but like, what does that mean? The distribution of probabilities for what? A
Random variable.
random variable. So remember, a probability distribution is the distribution and it shows you every random variable value and their probabilities.
Was that the, okay, when we were doing that problem the other day, and it was like that guy, like, you know, scamming his finances, and it had like the first digits of his expense report, was that a probability distribution?
We did not create one. It's a probability distribution. Closer to think about is, remember when we had like someone knowing 1, 2, 3, or 4 or 5 languages? That's your random variable, and then we have the probabilities with each of those number of languages learned, right? The combination of random variable with the probabilities is my probability distribution. Beginning of today with the corner bet and the red-black bet, we had the random variable of how much money or you won or lost. With those probabilities, those were 2 different probability distributions. Okay, Tyler,
Is it always a discrete variable?
binomial,
Yeah.
yes. Can you have 1.5 trials?
No.
No, so it's, when you talk about the number of trials, it's 1 or 2 or 3 or 4 or 5 trials. So it has to be discrete.
What about the, oh, yeah,
Does that make sense?
yeah.
So like the number of trials, the number of successes are discrete values. So it is a type of discrete probability, or discrete random variable. Okay, that's a good question. Alright, questions about binomial random variable or binomial distribution? Deacon wouldn't know because he's got his head up.
My dad texted me about my fastball.
I guess that's kind of important. By the way, do notice here with this binomial PDF, right, that we ran earlier, this is not, hey guys, this is not a probability distribution yet. It's not a binomial distribution yet. What do I need?
Let's see.
Well, I can make it into a table, but there's something that would be missing from the table. I need to define my random variable x as what?
An integer.
Remember, for this situation, we were doing what? We were rolling dice, and x was my number of,
Success.
what was the success though? Number of sixes. So the random variable x is my number of sixes rolled in 4 trials. And so here's my probability of that variable. And so this was the probability for how many successes?
0.
0 sixes,
1.
1 6, 2 6. I finished it out. That's now a probability distribution. That's a binomial distribution when I have the variable with its probability. So when I put the variable and I define the variable and I put the probability with it, that's a probability distribution. And because this was a binomial, it's a binomial distribution. You good with all that? Questions? Comments? Concerns? No? You sure, Leah?
Yeah.
So you're getting all this even though you're doing a lot of drawing?
Yeah.
Alright, conditions. What is a binomial random variable? What are the possible values of a binomial random variable? Has anybody picked up on it yet? Yeah. What's the lowest possible value for any binomial random variable? Like the
0.
lowest number of successes. Lowest number of successes is 0.
To 1, 2, and then all the way to whatever n.
All the way up to the n number of trials, right? Because you could have all successes. So so for a binomial random variable, the lowest number of successes possible is always 0. The highest number of successes possible is n, the number of trials. Hey, I want you to look back at your formula sheet under binomial distribution. See what? Okay. If you look at the bottom of that binomial distribution, what does it say where x can be equal what? 0, 1, 2, 3, all the way up to n. Yeah. Notice they have told us what the possible values for a binomial distribution are there.
So it's just
And that's why what is a binomial distribution is a special type of what? You asked about it earlier.
Discrete.
It has to be discrete, right? Binomial is just a special type of discrete. Okay? So parameters. What in the world does that term mean?
Population.
Yeah, those are population values. So what are they referring to when they say parameters? The
Entire sample.
well, not the entire sample, the entire
Sample space.
sample space, which we would call that, what Tyler said, our population, but it's something about that population.
Probability.
Parameters, those are like, I have it written.
It's statistics.
Statistics for population.
Well, no, statistics for the sample. Parameters are for the population. But what were some statistics that we've studied?
Average.
The average, also called the
Mean.
mean. What other statistics have we studied? Median,
Standard deviation.
standard deviation, right? So what are some parameters to think about?
Population mean.
Population mean,
Population mean.
population median, population
IPR.
standard deviation. I wonder what in the world those parameters might be.
Let's find out, right?
Yeah, let's find out. Where can we might maybe find that out? Yeah, for sure the textbook, right?
The spreadsheet.
Google.
The calculator?
I feel like it's right there on your page.
Which page?
Excel
okay.
has a linear
Oh,
distribution with
wait a minute.
between-
Now be careful, you're looking at geometric now. We want what? Binomial still. Look at your formula sheet. What's that second column in the formula sheet?
Mean.
The mean.
U of X equals
N times V.
So what's the average number of successes in a binomial distribution? It's the number of trials times the probability. Hey guys, if I were to roll 6 die, it's not, or 6 dice, it's not 100%, but if I roll 6 dice, how many 6s would I expect to see?
1.
I would expect to see 1, right?
Yeah.
1 success. So the number of trials is 6 times the probability of getting a 6. I would expect to see 1. That's the average, right? So the average of a binomial distribution is just the number of trials times the probability of success. Notice it's not as complicated as the discrete random variable. It's just the number of trials times the probability of success. What's the other parameter that we see there?
Standard deviation.
Standard deviation of x. What does it say?
It's the square root of NP times 1 minus P.
What does that mean?
Square root
Number of
of mean
successes.
times complement.
What's,
The probability.
oh, that is the mean, isn't it? Once again, the mean is kind of an important part, isn't it, for
Yeah.
standard deviation? But just in on its own, that's my what?
That's your
Number of
trials.
trials.
And that's the probability of success. And then
Okay.
that is a complement to the probability.
Which would be the probability of failure.
So that's what 1 minus P is, that's a complement?
It's the complement, right? So like if I take P and I add the complement to it, like if I take P
It's just the other half.
plus 1 minus P, what would I get?
1.
1, right? So that is just the probability of failure, right? So standard deviation, and notice the square root is there because the variance, which we don't really need it very often, but the variance would just be n times p times 1 minus p. And we take a square root. Standard deviations, there's always a square root involved. Because what did we do? We squared something. Okay. But again, do you need to memorize that formula? No. You can get it off the sheet. Yep. And I will say, like, this one is one I'm not going to put in the calculator because honestly, like, sorry, I'm not going to use, like, lists and spreadsheets. I will just put this on a calculator page, right? The square root of the number of trials times probability of success, yada, yada, yada. Any guesses what the most common mistakes students make on a binomial distribution question and things that you need to be careful about?
They probably forget to take the square root.
Maybe. Now, I will say it's not the biggest one for me.
Does it matter about like population or sample?
So we're always gonna, so remember when we deal with a probability distribution, it's always a population, right? So it's a good thought.
So can you not do probability samples?
Do people confuse N, which is the number of trials, for the number of successful trials?
Yeah, that actually is a pretty common thing, right? So we do want to be careful. N is the number of trials, whereas X is the number of successful trials. That is a common mistake, but it's not the number one issue. They forget to check something.
Check if it's actually a binomial distribution.
Check the conditions. They assume that it is or is not. They don't check the conditions. You got to check the bins, right? Is it binary? Are the trials independent? Is there a fixed number of trials? Is it the same probability all the way through? The number one issue that students run into is they forget to check the conditions. The second one, and this is one that a lot of y'all did on the normal distribution stuff as well, is they use calculator speak, meaning what you see in the calculator is what they write down, without identifying what the values mean. Or showing in the formula. And my recommendation is showing in the formula. But you can, it's like that is stronger evidence. More AP readers prefer seeing you like literally substitute a couple of values into the formula and then just put ... That's what they prefer to see. Because are we going to use the calculator to calculate these things?
Yes.
Heck yeah. But do they need to know that you understand what those values are? Yeah, they need to know that you understand N is the number of trials, that X is the number of successful trials, that P is the probability of success. So personally, I'm always going to substitute into the formula, because if I substitute into the formula correctly, I know what I'm doing. And that's what the AP readers see as well. So check your conditions, make sure that you don't, so the most common mistake is just using calculator speak without identifying those things. Don't do this, right? I'm going to check in the book to see if there's anything else, but and tell you tomorrow if there is. But that's the major things that I remember off the top of my head. Okay. So, yeah. Nope, never lie to use the restroom for the rest of your life. Sucks to suck.
Yeah, you can't go there.
I know. Alright, so if we roll a fair die 4 times and we let X be the number of successes, is that a binomial distribution?
I guess so, yeah.
How do we know?
It's a fair die.
It's independent, success or failure.
Okay, so start with the very first thing. What was you said success or failure, so it's binary.
Binary. It's independent because you're rolling a die.
Independent trials, one trial does not affect the next.
Same probability.
And so that same probability is at the end. What's the end?
4 trials.
4 trials, so it's a fixed number of trials. By the way, I just did BINS right here. Actually on the AP exam you would want to write out binary, check, right?
Mm-hmm.
Independent trials, check. Fixed number of trials, check. Same probability each time, check. And you can write more than that, but they want to see that you know what those conditions are and that you've checked them.
Can you go
Okay.
over same probability again?
It's just like every trial, the likelihood of success is the same. It's like if you roll a die, what's the likelihood of getting a 6 every time?
1/6.
1/6. Every time it's the same probability. Okay? So shooting a basketball 20 times from various distances on the court, let Y be the number of shots made. No? Which one's not?
It's not binary.
Is it not?
Probability.
It's not.
The probability is the same because you're shooting from various distances.
So like think about it. Is it binary? Like if I take this marker and I try to toss in that trash can, It either made or it didn't, so is it binary?
Yes.
No,
Yes.
it's the number of shots made, it's not whether or not you made a shot or not.
Well, remember, that's the random variable, right? So there's always gonna be the random variable, so 0 made, 1 made, 2 made, 3 made, 4 made, 5 made. The question is there just success or failure? And so, is it binary? Either you made the shot or you didn't. If you shoot a basketball, what are the two options?
Yeah, I get it.
Okay. Are the trials independent? Does one trial affect the next one? One shot affect the next shot?
No.
You think, bro, you get fatigued?
It depends on how it's shot, but given how the question's
Technically,
worded,
it's
I'm just gonna
mental.
take the.
I would say maybe there's some mental components to it. Maybe some physical fatigue. So maybe it's not independent, but I think based on the way it's written, we could say that. But maybe a check or an X. Regardless, that's not really the issue here. Is there a fixed number of trials?
Yeah,
How do you know?
20
you're
times.
shooting 20 times.
You're shooting 20 times, right? So is there a fixed number of trials?
Yeah,
Yes. Is it the same probability every time?
no,
So is it binomial?
no.
No, right? If one of those conditions is not met, it is not binomial. So binomial, not binomial. What about if you observe the next 100 cars that go by and let C be the color of the car?
That's not binary.
Yeah.
Is that true? There's not just a success or just a failure?
Well, yeah, 'cause it could be red,
It could be
yellow,
red, it could be blue, it could be yellow. So is it binary?
No.
No. So that's an example of not binary, right? Either making the shot, not making the shot, because that's the number of shots made. But C being color, that's not binary. So not binomial. How do we feel about that?
Are we not going through the rest?
Huh?
Are we not going through the rest?
Once you have one condition that's not met, it doesn't really matter. And so I will point that out, like I didn't have to go through all these here. If I had recognized that the same probabilities, it's not gonna be the same probability, then I could have just said, hey, the probabilities aren't the same, it's not a binomial distribution. Okay?
Should do this already.
For this one, yeah, calculators. Alright. So in general, how can we calculate binomial probabilities? Is the formula on the formula sheet? Yes, you can write out your formula sheet, or write out the formula if you want. It wouldn't be a bad idea, but it is on the formula sheet. Right? So the probability of x equaling x equals n choose x. But as another way, n combination x is also read as n choose x times probability of success raised to the number of successes times the probability of failure raised to the number of failures. You'll realize or recognize that I very rarely just say p and raise to the x. Like I read out loud what it is. Right? Number of trials choosing the number of successes times the probability of success raised to the number of successes. When you read that out loud like that, it's hard to forget what these things mean. Whereas if you just read letters, it's very easy to forget what these things mean. Okay? By the way, why in the world did I do a big X here and a little x here?
Because one is the random variable.
So this is the random variable x equaling what? This value. This is the probability that that random variable equals that value. Okay? Alright. So, roulette, 18 of the 38 spaces on the wheel are black. Suppose you observe the next 10 spins of a roulette wheel. First off, is this binary?
Yes.
Either it's red or it is
Black.
black. Actually, that's not true. There are
Green.
green as well. But it's either black or it is not black. So it is still binary in that situation. Does one spin affect the next spin?
No.
No, right? So are they independent?
Yes.
Yes. Are there a fixed number of trials?
Yeah.
What are the fixed number of trials? How many?
10 seconds.
10, right? Is it the same probability every time?
Yes.
Yes, 18 out of 38. So how would I calculate the probability that there are exactly 4 of the spins land on black, first off, I would write out that formula, right, on the AP exam, but how am I actually gonna calculate it?
I'm gonna use this formula on the calculator.
Yeah, so I'm gonna go, and I wanna show you 2 things with this really quickly. So, distributions, binomial, should I do PDF or CDF?
P.
Why is it P?
Honestly, this is what we did earlier.
Yeah, it is, but what does C stand for? Cumulative. So if I have more than one number of successes I wanna look at, I use cumulative. But binomial PDF is what I want here. Number of trials? 10. Probability of success?
18/38.
And then X value, how many successes did I want? 4. Right? So 0.2247. By the way, how many decimals do we go for probability?
4.
4, right? And so,
So what's our X value?
remember we wanted 4 successes, right? And so I'd write that out. The number of trials, choosing 4 successes, times the probability of success, raised to the 4 successes, times the probability of failure, raised to the 6
We're
failures.
going to go 4 digits.
4 digits on probability.
Okay.
4 digits on area, 4 digits on probability. It's always the same.
Looking at that.
What's up?
So, the 10 and 4, that's a combination, not a fraction, right?
Correct. You'll notice there's no fraction bar. It is that combination idea. But again, do you have to sweat the combination detail?
Maybe,
No.
Because aren't you just going to put it into the calculator and the calculator's going to spit it out for you?
Yeah.
How do I do a combination?
You don't have to. It's a binomial PDF.
Oh, wait.
Now there is a combination on the calculator, and I can show that to you, but notice I'm writing this out. I'm not typing this into the calculator. I'm writing this out so that the readers know I know what those different parts of the formula mean. Okay? Does that make sense? Like I didn't type that in, I just did binomial PDF. So, I want us to look at the next part here.
I think that would be binomial CDF,
Why would this be a binomial CDF?
because it's cumulative, you're going at least 8.
It says at least 8. So this time, it's not just the probability that x equals 8, it's the probability that x is
Greater than
greater than
8 or equal to.
or equal to 8. And then, so in this case, what's the number of trials again? 10. Choosing how many successes? It'd be 8 to
10,
start.
And then 10, choose now.
Well, not yet, because I need to finish this out, right? So 18 out of 38 for my probability of success, raised to the number of successes, times the probability of failure, raised to the number of, how many failures would there be?
There would be
2.
Right? 10 minus 8 would be 2, plus,
Oh my gosh, that's not good.
and then you rewrite it like for 9 and 10.
except after the 9,
You can do that.
could the, yeah, I would say the AEP readers, could they tell that I know this formula?
Yes.
Yes. So, dot, dot, dot. And then you know what I'm not gonna do? Put that in my,
Actually saw that on paper.
yeah, I'm not gonna type that into the calculator, what am I gonna do?
It is a binomial PDF function.
I'm not even gonna do binomial PDF.
Cumulative.
Yeah, notice I have more than one now, don't I?
Yeah.
So I'm actually gonna go down to binomial CDF. What's my number of trials? 10. What's my probability of success?
18 out of 38.
What's my lower bound?
8.
So notice this deacon is where lower bound and upper bound come in.
Yeah.
And what's my upper bound? 10, the total number of trials that I have. That's it.
So this was like, this is what I was asking the other day, it's like, can you do it if it's more than 1? I just like,
Oh yeah, you remember earlier when we looked at that case of at least 1, and we did 1 minus the probability of 0? Could you have also just done a binomial distribution where you did 1 to whatever the maximum number of trials was?
Yeah.
Right? If it's probability of at least 1, it starts at 1 and goes all the way to the max number of trials. Austin, you had a question?
Yeah, so on that point, do you, because I know on your calculator you just did the combination, the binomial PDF stuff.
I didn't do the combination at all.
Well, yeah, no,
Okay.
that's what I meant, but I did that, and then I also multiplied it by those other two things, so we still do that after.
Say that again.
Cause it's all like together, like I multiplied with the binomial PDF thing you came out with.
These are 2 different problems.
No, I was on top, I was feeling like,
Like you were trying to check to see if this gave you the same thing as the calculator?
no. I just meant they're all like, put together like they're all multiplied.
Yeah, they are being multiplied. But again, you don't have to worry about that because the calculator does all that work for you.
Oh, okay.
Right? So like it's understood that these are being multiplied, yes, right? Because there are 18 out of 38 successes 4 times, or the likelihood of 4 successes is 18 out of 38. The likelihood of 6 successes is 20 out of, or failures is 20 out of 38. So you multiply all those probabilities and here's how many ways you can get that. But the calculator with your binomial PDF and binomial CDF is doing the work for you. You just have to set up the formula. So the AP exam knows you know the formula. And that you know what the different parameters are. Because there is a chance that you just kind of guess and put stuff into a calculator and get it right. They don't want to see that, they want to see that you understand. Okay? I know, it seems overrated, but I promise it's
Yeah, that actually makes sense.
okay, so there are some homework questions associated with this. Okay, hold on one second.
At the bottom, look fine.
By the way, hey guys, how can you calculate binomial probabilities on the calculator? This is the next little piece of that. They have in the book how to do it on a TI-84. I live in the 21st century, so I use the TI Inspire. And so I would just make the note, you're going to use a binomial PDF when you want how many successes? Or just like one set number of successes, right?
You have like a range you use, CDF,
Yeah, because what does that C stand for?
cumulative.
Cumulative, right? So make a note of that.
What does the P stand for? I'm curious.
Probability density, or probability distribution function, a density function. Because remember how we didn't put the specific number of trials in, it gave us the probability for every single option? So that's a probability distribution. Okay, do this for me. I don't need you to do all of these. Goodness gracious. I'm gonna skip some of this. At least do this for me though.
And then the best.
Do this number of flips one for me. And this section here about mean and standard deviation. Okay, so this section, it says read 440 to 445. And I won't put any AP classroom stuff. I can find one. Yeah, so that whole page before 446. So, guys, that very next page, complete those up until you get to that last little bit, right?
Can we
So,
borrow the TI?
yes, you can borrow TI Inspire for sure. There's no way I'll have enough students here who need one today.
Oh, yeah.
It's so extra.
It's so
It is a logical fallacy. You are correct in that statement. Alright. Hey guys, I for real need you to get that done tonight. All y'all who are not here, I need you to for real get that done tonight.
How many of them?
Oh, that's why
are
it's-
gonna watch it? There's
Yeah.
1, 2,
I was so
3, 4,
confused.
5.
I'm going to post it on YouTube right now, and I'm going to